everybody, welcome to Marketing Analytics course. This is Dr. Shagata Chatterjee from GSOM IIT Kharagpur who is taking this course. So this video might look a little bit different from the normal NPTEL videos because of this coronavirus that is coming up. I could not go to the studio and I have recorded this particular video from my house. So we are in week 12, the last week, and we have been discussing about uh, social network analysis. And in this particular class, I will give you a very nice example of social network analysis, how that can be applied in a real life situation. So I don't know whether you have heard about something called bullwhip effect in logistics or not. So if you if I discuss about what a bullwhip effect is, bullwhip effect is basically a effect that can be seen in a supply chain context, where let's say I by chance have uh, some misprediction. So there is basically uh, the supplier, the retailer, the retailer, and then comes the let's say the supplier, and then comes the let's say the warehouse guy, then comes the manufacturer. So if this was a small whip here, which is basically an error in estimation of the demand, and his information gets passed to this guy who is a supplier. Then this becomes more further higher, and here it becomes further higher. So it looks like a bull whip. See, you're giving a small whip in this portion, and it becomes a big, huge whip in this portion. So that is what we generally try to find out. Now, there was a training program that I was taking with an organization on oil and gas, and there I was taking this particular program. And there I have demonstrated a supply chain game in that particular thing, that there is a supplier, there is, let's say, in the supply chain of this particular company, there are retailers and then the wholesalers and then the manufacturers. Manufacturer is the organization that, but this organization also takes into account the retailing part. And in the whole chain, there are many various people who can take a call that how much has to be produced, how much has to be delivered, and etc. So what I found by taking this uh, particular test was that we made two groups, and these two groups played, and our major goal to this particular groups was to tell that okay, you have to reduce the costs of this I would say estimation or misprediction. The higher you do misprediction, the higher will be your costs. And obviously, one group did lower misprediction than another group, and that group won. Now, till now, each group had four members or four groups. Each group has actually four subgroups in them. One subgroup is the retailer, one subgroup is the wholesalers and manufacturers and warehouse persons. But I did not let them talk with each other. Means the groups, subgroups will talk within themselves, but retailer will not talk with the wholesaler. Wholesaler will not talk with the manufacturer, and etc. They will give these orders based on or make their predictions based on their idea of whatever is order coming up and etc. And that created a bullwhip effect. Now, generally, this bullwhip effect will come down when we allow some sort of data sharing between them, because the more information sharing happens, the I would say the uncertainty reduces, and when the uncertainty reduces, people make better decisions. So what we found from this kind of an analysis is that after after we broke this particular thing, after we allowed them to talk with each other, the group which was bad in the first round did pretty well, and actually they could reduce their cost in the second round. But the group that did good in first round, it is very astonishing that they, even after data sharing, information sharing, they did worse than the first round. Not only did they fail in the second round, they did worse than the first round. So then we tried to analyze that what happened, why they failed. And we could probably find out that in the these are all the guys are coming from the same company. Now in the same company, though they are in various roles, they have hierarchy. They know that okay, this person is general manager. Whatever he is saying, I have to follow that. If he is saying that order 10 bottles or 15 bottles, I have to order 10, 15 bottles because even outside this training program, he is my boss. So that kind of a social pressure, social connection comes into this kind of games as well. Now we try to see that whether things are there in terms of the. So this is so what we collected at the early means even before the game started, we collected this data and we did a survey with them actually before the games, before anything started. So some name of the officers I masked it, and please let us know the top 5 persons in this group with whom you communicated the most. Also let us know in a 1 to 5 point scale how much was the communication. 1 means few communication and 5 means high communication. So this will be creating something like this kind of a matrix where there will be around, I don't know, 24 people here in the row, 24 people there in the column, and a matrix will get created. Let it open. And the matrix will, okay, 20. The matrix will get created. 0 means no connection. See, diagonal elements is still 0. And then 4 means high connection, then 5, then 3, and so on. And we took an average, closest or the highest probably. We took the highest. If 1 is saying that I have talked 3 times with 4, and 2 is saying I am talked 4 times with 1, then we took the highest of them. This is our choice, you can take anything else. And then with our R programming, we try to create uh, this kind of charts or graphs. And let us see that what these graphs are. Let the R program open. Yeah, it is opening. Okay, so it has opened. And if you see here, snapatch.r, the first thing that I do is I set working directory to source file location. Then I read this data. As usual, remove the first row and read the batch details as well. Now the library that I will call is iGraph, and then I will make the graph, simplify the graph, and then I will put the level names, and then I will plot it. So once I plot it, the plot has come up here. It just zoom the plot, and you can see carefully that there are V2 and V1. These are one of the most important ones, and these three guys have not talked with anybody. Now, if I want to plot it in a better way, and that's this one, which we were playing with in the last class, it will create a pop-up. Let the pop-up come up. Yeah. So, and now if I just zoom it, then select all vertices, and then make the color white. Okay. And then the layout is, let's say, this one. I can see that V1 is the middle one, not even V14. V14 is not that connected. There are only 4 connections, but V1 is the most important person, who is probably the head of all of these guys. And then probably V14 has some connections. V2 also have quite a few connections. And here probably not else. So V14, V1 and V2 were the major connections that we have got out of this kind of a analysis. And then if I just plot it in a better way, to plot the I would say the mm, paths also according to the weightages, if I try to do, and then I am putting the shapes as rectangle, circle, square and pi based on their position, and then based on the position I have done that, and then I try to plot this. So see, shapes are like this, the 4 shapes, and based on the details designation and this thing I am varying it. So if you just try to see this one, you will know that this V1 is a big circle, and then V2 and V13, so V2 and V14 were also measured, and then V13. So most important is V1, then come V2, V14 and V13 were similar, and these guys are not connected with anybody. So that gives me an idea that who is connected, and these positions which are like different shape, star shape, are basically peripheral. They are not central in any of these things. So who are this raster shape? So we have to check that who are this raster shape. This basically it will come from details. So you see that this is the raster. The raster is a senior managers basically. And then V1, who is the most important one, he is a circle. So chief manager is a circle, senior manager are rasters, and then senior depot is pi, who is not even there, and then probably rectangles are assistant managers aims, who are thus who, if you check it here, were the last guys, were the outside guys. This guy, this guy, this guy. They have V19, V20 is still central, but V19, V15, and V16, nobody knows them. But they are basically DGM and a assistant manager. So based on the designations we have given this particular. So obviously the chief manager is the central. If you want to see that carefully, the V1 chief manager is central and not the V2, which is also a important thing that you have to understand. That V1 is more central. Actually, V2 is also central, but V2 is relatively less connected than V1. And actually, when we saw the bad performing one, was because of this V1. This guy was taking too much into too much effort, or too much, I would not say effort, he was influencing too much to this group, and which was a wrong influence, unluckily. And that's why his influence actually worked a lot. So people didn't take decision based on the data, people take decision based on whatever V1 is saying, and that impacted the results ultimately. So this is how even in organization culture, the social network analysis comes into the picture. It was a nice case study that I wanted to present. So thank you very much. I will see you in the next video with an absolutely new topic. Thank you.